Let's discuss lubricant mix-up. What is it? It describes any situation where the lubricant that could be new or in service is not 100% of what the specification requires. Why is it an issue? Well, if you don't have the right oil in your system or you have a little mix in there, you could end up with some premature wear, you could get some corrosion, you can get some machine performance issues like excessive foaming, things like that, or you can get a situation where the lubricants are not compatible and there's a miscibility problem which leads to pumping and starvation issues. How do we detect fluid mix-up? There is no single test available that describes what this is. However, a routine on-site test looked at together can provide some information and clues to actually what's going on. Major tests of interest would be things like additives, viscosity, infrared fluid integrity, particle count, total acid, total base number. Looking at all of these together can indicate when you have lubricant mix-up. So there are different scenarios for lubricant fluid mix-up. You can have a situation where you have a brand new oil A and a brand new oil B, and the viscosity is exactly the same, but the additives are different. And in that situation, your additive elements are going to make a big difference, have a significant effect, and the other tests will provide some information, as you can see on this table. You can also have a situation where you have the same situation, but the viscosity is different. In that case, your viscosity measurement may be the first clue that something is wrong. Other situations that can occur is where you have a new oil and an in-service oil where the additive packages are quite different. So you can see here with these tables that there's a variety of different ways that we look at detecting fluid mix-up. And each test has certain strengths depending on the fluid mix-up condition that you're looking for. One thing we want to bring to your attention is this new feature that we have on the mini lab systems with Fluid Scan, where the Fluid Scan now offers you a fluid integrity reading, which allows you to be able to see a change that occurs possibly due to fluid mix-up, but of course it can also be changed because of normal contamination that may be present in the system. The best way to detect lubricant mix-up is to have a routine condition monitoring program. You can have that with your on-site equipment, where you're actually testing your oils on a regular basis. In that way, when there is a change from the original values, you're able to detect that very quickly. Let's take a look here at a couple of examples of where lubricant mix-up is a case. In the first case here, we have a situation where we have a turbine oil, and if you look at the previous results and then you compare the current results, notice a couple of differences here. You've got a big change in your additive elements. Your viscosity hasn't changed that much. You have a little bit of an increase in acid number. You also see a slight increase in water content, and your fluid integrity has changed a little bit as well. The additive elements are so dramatically different, and the nature of those are such that looks like they're coming from engine oil. So it looks like engine oil was added into this fluid. So it's a clear case here where you've got a fluid mix-up, and all tests are indicating that. But the most convincing evidence is from the elemental additives. Now let's take a second situation which is quite common, and that is where you have maybe a specified synthetic product supposed to go into a gearbox application, and instead of that you have something like a mineral oil that has the same viscosity but different additive packs. And if you look at this situation here, your viscosities are the same, but your additives are not that much different. There's a little bit of a lowering, but it's not conclusive by any means. Your oxidation is quite low, your acid numbers are quite low, but if you notice, your fluid integrity has seen a change. So that indicates that there is a change. It may not be a performance-based issue right now, but there's certainly some differences there that you need to keep an eye on. As we mentioned, you can see the differences depending on the tests. You can flag those by using your alarm-based systems. Our TrueView application allows you to modify the alarm so you can tighten in those specifications and see when there's a change. The question is, what do you do when you do identify that change? What are your options open to you as a maintainer? You've got really three major actions. The first one you can do is change the oil out. That's probably recommended for small gearbox applications and in certain industries such as nuclear, food, aviation. It's better just to change the oil out immediately and not have any risks. In other applications such as power plants where you have very large reservoirs, or in refineries, you may elect to do a feed and bleed. Yes, there's an adulteration. You can certainly see there is a change, but it may not be affecting performance, and you work it out by doing a change and add as you go along. The third option is to do nothing immediately, but monitor it closely. Just watch to see if there's any change in conditions, any abnormalities. We also call that nursing the equipment. You may elect to actually sample much more frequently and use your on-site solution to be able to detect that rapidly. In all cases, you have a solution to solve for fluid mix-up and eliminate that problem from becoming an issue in your facilities.